Welcome to the AI in Manufacturing podcast here on Industry4.tv. I'm your host, Kudzai Manditereza, and today I'm joined by Pugal Janarikaman, who is the Global Manufacturing CTO at Snowflake, and we will discuss transforming manufacturing with AI and Snowflake data infrastructure. Pugal, welcome to the show. It's such a great pleasure to have you on here.
Thanks, Kudzai. It's a pleasure to meet you as well. I think we have been talking about this for some time. Finally, the stars aligned, so we are able to do this together. Thanks again for the invite. Looking forward.
Oh, yeah, absolutely. I'm really excited to finally get a chance to have a chat with you. So, maybe before we dive into it, could you start by introducing yourself to our audience and
Yeah,
also share a bit about your role as the Global Manufacturing CTO at Snowflake?
yeah, definitely. I think I'm in this role for last close to 2 years now in Snowflake as a global manufacturing CTO. Again, the role entails pretty much building higher order solutions on Snowflake to accelerate digital transformation of our manufacturing customers. Again, when we say manufacturing, it's kind of loosely defined in Snowflake. It's not just manufacturing as in running production, supply chain, traditional Industry 4.0 use cases. It includes R&D, it includes connected products, connected mobility, pretty much all of it. I deal with all of those use cases, even though the journey started for Snowflake a year back when we launched Manufacturing Data Cloud. Was all around smart manufacturing and supply chain. How do we accelerate that with solutions we built and products we launched? And that's what it was all around. 2 years in this role. Before that, close to 4 years, I ran the industrial IoT and manufacturing practice at AWS globally as well for 4 years, close to 4 years. Before that, 20 plus years in Siemens, been working with manufacturing customers around the world for a long time and building these kind of solutions. Yeah, that's what I do.
Awesome stuff. So, yeah, from your perspective, what are the most significant challenges in manufacturing today, and how is AI best positioned to address these? And maybe if it's not just like challenges, but missed opportunities that you see AI unlocking for manufacturers.
Yeah, definitely. I think, as you know this well, the biggest challenge in manufacturing, it's true for most of the areas in the industrial world, but in manufacturing more so as in running production, getting good quality data is the biggest challenge. It has always been a challenge, more so when you look at the types of data needed in the manufacturing world for you to get deeper insights and streamline your production processes. It involves both IT data as well as OT data, as you know well. The more so the challenges I have seen, been in the middle of hundreds of these Industry 4.0 initiatives for the last, I would say, close to 6+ years or 8 years, something like that. It always comes down to the quality of data, and are also a couple of years back, it was difficult to even get the OT data. There was a lot of coding involved and understanding various protocols, data formats, and challenges like that. A lot of those problems still remain. Quite a bit of it has been streamlined. I would say that if I have to pick an area, the biggest challenge it's always availability of good quality of data, and also data with the right contextualization. It's not just moving a swamp of data from edge to the cloud. It's having a data with the right context, with unit of measure, meta model, plant hierarchy, asset models in place, so you can make sense out of it. That challenge has always remained in the industry. I would say that that is the biggest hurdle for adopting AI and ML in manufacturing space. Frankly speaking, that's where we spent a lot of our time in Snowflake as well to fix those issues. Anyway, we'll talk about it. So
Yeah,
I would say
absolutely.
that's where the industry is today.
Absolutely. So when you kind of like look at what manufacturers typically want to do with the data, what are the kind of like the most common use cases with data that you see out there?
Yeah, I think the most common use cases in manufacturing world is, hopefully they have access to the data.
Yeah.
Once the data is available with the right context, IT and OT data, all of those data sets available for them, making sense of the data to understand trending, to understand patterns. That's where we see the biggest application of use cases in real world. That's where we see also the AI and ML playing a significant role, where it is already doing that today. Because with the volume of data, as you know, even for a single machine, you are looking at a couple of thousand tags in even for a pretty simple machine. Larger complex machine, you're looking at a couple of 100,000 tags every microsecond coming out of those assets. You're looking at a lot of data points being collected at every facility. Making sense of this data, understanding trending, anomaly detection, human mind cannot comprehend that volume of data. That's what people have attempted in various operation centers. If you visit manufacturing facilities, you can see a whole bunch of HMIs and dashboards on the screen and people monitoring it manually. You can monitor that for a bunch of values, but not for thousands and thousands of parameters coming out of these assets. That's where the industry wants to go. That's where I can see already AI being applied successfully. Even the foundational things, can I understand the trends on this data being coming over? Maybe whenever the vibration exceeds certain threshold and the temperature is so and so, I'm producing bad quality part, or my throughput is not good enough. These kind of trending and anomaly detection is where the biggest interest is there, to use AI and ML to go and make sense of this data, even before we get into far more advanced use cases like anomaly detection and stuff, or predictive maintenance use cases like that. So
Awesome. I mean, what is kind of like become evident over the past decade, and even by the way you describe those kind of like large volumes of data, hundreds of thousands of tags. So what is quite clear is that for AI to be successful, you definitely need to have a robust underlying data infrastructure to handle the kind of volumes. So in your view, what would you say are the key characteristics that a data infrastructure should have in order to enable successful AI deployments in industrial in general, but specifically to manufacturing?
oh, definitely. I think I would say there are three key criterias which we have consistently seen with the customers. And as part of the evolution, even the customers are going through. Pretty much every product manufacturer, machine builder is adopting the digital world and trying to make this more and more a service driven approach than supplying a product. That's a trend we are seeing. In line with the trend, I would say there are three foundational characteristics are so important for them to be successful in this journey. The first major foundation is the data foundation. Do you have the right data foundation which is able to ingest all this kind of data, various data sources which is out there, bring the data in scale at the lowest possible cost, highest possible fidelity, preserving the contextualization, and making the data available, and also scale the value realization process with adopting AI and ML. The third major component, which we are seeing more and more with a lot more advanced customers we work with, every one of them want to build data products and monetize the data. They want to take the data they are collecting from their machines they are supplying to welding or final assembly, whatever parts they are supplying this into. They want to provide services like maintenance as a service, quality services, stuff like that. For that, they want to work with us to build joint data products. This brings in a whole new set of pressures on machine builders who do not know how to do this. They are expecting support from partners like Snowflake who can bring in the knowledge for them to go accomplish these things. That's what we are looking at when we are working with customers on this front, to set the data foundation up where they can ingest this IT and OT data in scale at the lowest possible cost. And also the value realization process, at least in Snowflake today, we don't expect them to learn hundreds of services, underlying services needed, elemental services, which a cloud vendors usually provide. You make sense out of it and build an application for maintenance or quality control. For us, it's one single service. We take care of all the underlying cloud vendor complexity, and we take care of security, and we don't expect the customer to export the data out for running analytics. We bring in the compute next to the data and make sense of the data and help them on the data value realization process as well and monetize it with modern data sharing techniques where you don't ship the data around, you share the data. And when people want to access the data with apps you are building, like native apps, what we call it as, the people who are accessing the data, they pay for compute, while as a data provider, you only pay for the storage. A lot of techniques like that are in place today, which we are adopting as well.
Awesome. So maybe let's kind of like jump into your Snowflake's manufacturing data cloud platform. So I mean, as you already mentioned, in early 2023, I think you were instrumental in launching Snowflake's manufacturing data cloud, which has emerged as a major platform for supporting things like AI-driven initiatives in manufacturing. So first of all, could you speak to us about what was the main driving force behind launching such an offering? And then could you kind of like give us an overview of Snowflake's AI Data Cloud for manufacturing?
Yeah, definitely. I would say there are two key characteristics which was involved in launching the manufacturing data cloud last year. In fact, we did this last year, April, in Hanover Messe. Obviously, it was a team effort. It's not just me. I set the solution strategy, working with a whole bunch of industry team who are responsible for identifying use cases, things like that. The foundational capability, there are two things again associated with it, as I said. One is the foundational core product capabilities we built and launched as a core product. It's available whether you are a manufacturing customer or a financial customer or any other industry vertical. If I have to pick two foundational capabilities, obviously there are lots of capabilities. One is time series data management. Hugely interesting for customers to manage OT data or connected product data, connected mobility data coming into the system in one single database or data platform, where you can manage both the OT data as well as IT data, transactional data, and then mix and match to drive IT and OT convergence. We all know that it's a super important capability needed, and it's all happening in one single platform. If I have to point out other core capability we launched is support for GPUs. With GPUs, as you know very well, we can build convolutional neural net models, which is foundational for building a computer vision based quality control kind of solution. Again, we can talk about that later if needed. So these are the kind of foundational capabilities Snowflake product group launched. So as part of our CTO organization and industry manufacturing vertical organization, we worked with more than 50 plus partners to build pre-built solution offerings on top of these foundational capabilities, which can accelerate the smart manufacturing, smart supply chain journey of our customers. Because all the focus last year, April, was all around powering smart manufacturing and supply chain. So if I have to point out one capability, we worked with partners like with HiveMQ as well, partners like Inductive Automation, Cirrus Link, Opto22, players like that, to launch one of our very early solutions to ingest OT data in scale with zero coding. Again, I think if I have to quote Mr. Walker Reynolds, it's collect, connect, collect, store, visualize data. I think that's pretty much what he always talks about. I'm a big fan, by the way. A lot of work we did in manufacturing data cloud launch last year, April. My North Star was always principles, and that's what I applied for a lot of those things. In fact, if I have to point out one key capability which made a foundational shift to our presence in the last 12 months after the launch, is the OT data handling capability. If I have to point it out, we took an OT first approach there on the solution, where we said the OT world is not going to change. We are not going to come up with a service in the cloud and expect that world to change. But whatever we do, we have to recognize that, bring the data in scale at the lowest possible cost, preserving the contextualization, where it is all edge driven, as we know very well. And it's MQTT, published by exception. And this onboarding of assets, manufacturing assets on a plant floor, for example, cannot happen with coding. The minute you bring coding into the picture, onboarding thousands of assets, millions of assets, even for a single customer, this is not a scalable problem, always failed in the real world. So we took a code-free approach to onboard an asset. We can handle every possible protocol at a plant floor. We can ingest the data from any machine, PLC, SCADA system, convert that into MQTT, and then send it into Snowflake natively without any coding. And so by this kind of approach, we have completely accelerated the value realization process for customers taking the smart manufacturing journey, where we have commoditized the complete data ingestion process, which was considered as extremely complicated, more so from OT point of view. IT people have already done that. So that is the kind of differentiating capabilities we launched, which put Snowflake solidly in the map of manufacturing globally, and we have so many engagements happening around this topic. So.
Yeah, absolutely. And I certainly must commend you for taking that approach. You sort of like follow the teachings of Walker Reynolds. He always talks about this idea that manufacturing is it's a chaotic environment. Things change every day. Lines get rearranged and things like that. So you always want to follow what's happening on the shop floor. You don't want to detect from IT going down there. So those are some of the things that I really found compelling when I sort of like read up on your platform and the approach that you're taking there. So that's really interesting.
Yeah, absolutely. I think again, it's not just one individual. If I have to point out another person who shaped the Snowflake's manufacturing strategy a lot, it's Arlen Nipper, as you know well, co-inventor of MQTT. In fact, he's the person I called when I took this role around 2 years back. On literally, I walked to him with a clean sheet of paper and told
Yeah,
him that, hey, you know what? I need to set this manufacturing strategy for Snowflake. We have learned a lot, because I worked with Arlen closely in my AWS days to set the industrial IoT strategy as well there. We learned a lot, made a lot of mistakes, obviously.
yeah,
So with a clean sheet of paper, my message to him is, can we eliminate coding? No coding at the edge. Can we also take a completely MQTT based approach to send the data to the cloud in a standards based way? We again took Spark B as one of the standards we support. Again, we are not exclusive to any particular standard. We support anything customer wants us to do. So, and we achieved it. I think worked closely with Arlen, inductive automation team, with Don Pearson, Travis Cox, Benson from Opto22. All of them collaborated with us to launch and make this super successful. Obviously, always North Star principle is Walker. With I'm a big fan of his podcast as well. So.
100%. Yeah, so I mean, you have already alluded to the fact that really one of the most challenging aspects of digital transformation in manufacturing is managing this data across different silos in manufacturing operations, because this is often a complex task. And as a consequence, this lack of integration hinders AI implementation at scale. Now, my question for you is, how does Snowflake's Manufacturing Data Cloud simplify operations and management of data for manufacturers? So I know you've spoken about this at high level. Could you maybe elaborate on specific features that makes this process more seamless?
Yeah, definitely. I think in addition to what we have done as part of core capabilities, and also solutions we have built with a whole bunch of partners involved here. Obviously, we built a whole bunch of connectors with you at HiveMQ and a whole bunch of other players as well, like HiByte, folks like that. What we have done in Snowflake is mainly the value realization process acceleration, Kudzai. I think that's where we spend a lot of time, where we try to commoditize the data ingestion process, keep the cost as low. The other one is, once the data lands, what do we do next? Even there, we don't expect them to go figure out of hundreds of elemental services a cloud vendor can provide, and then say that, you know what, I need these 30 services and I trying to build an application around it, manage security associated with it. We eliminated all of it. It's one single service with us. So that whole journey gets much more accelerated for a customer. And also in parallel, we are also working with a whole bunch of players to build higher order solutions. We launched accelerators as well. On top of it, Snowflake built it. This is freely available. If I have to point out, for example, OEE accelerator. Every customer wants to calculate OEE. Whether they do it on edge or the cloud, it's up to the customer use cases. But a lot of customers wants to calculate it. Is there any pre-built code available? We provide a freely available GitHub repository with code on how to do that in Snowflake, along with data examples, so which they can take and simplify it and adopt it to their own requirements. These are the kind of approaches with which we are accelerating the manufacturers to realize the value sooner than later.
Awesome. So really, the what I kind of like here also your North Star really here was about really reducing the time to value, consistently working to reduce the time to value from the data investments, right?
Right. Yeah.
Awesome stuff. Now we've spoken about also the this issue of supply chain performance, also being able to manage that. One of the things that have become a state of default existence, as it were, since the times of COVID, is the volatility of the manufacturing supply chain. And I know that you kind of like also working towards helping manufacturers, enhance their supply chain efficiency. Uh, could you speak to us about the ways that Snowflake's data cloud for manufacturing helps manufacturers in that regard?
Yeah, definitely. In fact, the biggest presence for Snowflake, even before we launched Manufacturing Data Cloud, has been in supply chain area. One of the core capability which is getting more and more interest with supply chain is around data sharing between, for example, if there is an OEM out there working with their tier one suppliers, there is huge amount of data sharing needs between both of them. Traditionally, this involved moving the data from one location to another. This always comes with security challenges, pricing issues, a lot of those issues, and who's going to pay for it, for data storage, the compute associated with it, and all of those things. Here again, Snowflake has built multiple differentiating solutions, highly popular in other industry verticals, not necessarily in manufacturing, but in financial sector, in other areas like that. For example, healthcare, life sciences areas, areas like that. We brought those best practices into manufacturing world as well. So what does it mean? For example, if an auto OEM is trying to work with tier one auto supplier for a bunch of parts they have to supply, they have to share the quality information. Supplier has to share the quality information. Or in today's world, pretty much every OEM wants to have a deeper insights into the manufacturing capacity, the quality mechanisms happening at the supplier side of the world. That involves something way more than shipping data across. That involves modern ways to do sharing insights on what is happening in your facility to somebody else outside your organization. The way in which we do that kind of capability is like modern techniques like data clean rooms, where, for example, if a tier one supplier wants to share data with an OEM, they can point the data to the OEM they want to share the data with, where the supplier only pays for the storage. And the OEM who wants to access the data, they pay for the compute. So, and the data is never moved from one location to another. And this can happen across two different cloud that both OEM and the supplier can use as well. Hugely powerful mechanism and transformational in data sharing methodology between an OEM and a supplier. For example, this is one core capability which has got huge amount of interest. And also COVID, as you mentioned, brought up a lot of questions from the supply chain side of it. How do I identify supply chain disruptions like COVID, right? For example, one of the question which came up is, for if there is an earthquake happening in South America, will my supply chain network going to be disrupted? Do I have to look for an alternative supplier? There are a lot of applications which has been built now on Snowflake, working with partners who provide this kind of capabilities as well. In addition to that, if I have to point out one other area to close this out, whole bunch of connected product data is being managed in Snowflake today. A lot of supply chain logistics operators do that today and use the data to be shared with the OEM. For example, if they're doing just-in-time manufacturing, even if the inbound truck is 15 minutes late, you got a problem of a line starving without parts being available. You need to understand the dynamics of inbound supply chain, so you can make an alternative arrangement if needed, or produce something else if the parts are not going to arrive in time. The same thing is true for outbound logistics as well. For managing your yards, your inventory management locations, areas like that. So we play a significant role in ingesting that kind of data as well into Snowflake and providing deeper insights for supply chain operators and partners who want to build solutions on top of it and monetize the data and sell it to various OEMs who want to look into flexible manufacturing, for example. So that's how we are helping the supply chain side of it, Kudzai.
Awesome. Yeah, and it sounds to me like also the idea of limiting the movement of data from point A to point B is really kind of like really where you uh, sort of emphasizing on as far as the solution is concerned, and only sharing data with whoever needs access to it. And maybe at the risk of getting too technical here, what sort of uh, uh, eh, mechanisms would one be able to expose their data to, say, a supply chain partner?
Right. I think the simplest mechanism to do that is we call it as private data share, where you can share the data to precisely a certain individual or an organization with security regulations. For example, if an automotive company wants to monetize by usage-based insurance, they can identify a set of VIN numbers and say this insurance provider can only access this vehicle data for these VIN numbers, not the rest of it. It can be a direct private data share. So the insurance provider at any point in time, they can access those VIN numbers and compute all the other things needed on top of it. If they want to build additional products, data products on top of it, which they do today on Snowflake, that is the simplest mechanism to do that. There are additional complex mechanisms, like not a complex mechanism, more sophisticated mechanism for handling additional requirements with data clean rooms kind of concepts. And as I said earlier, this works seamlessly across any different cloud. Both the sharer of information and the person who's consuming the information can be in two different cloud platforms completely. Snowflake can seamlessly help facilitate the data sharing. Without data movement and analytics, you can perform with monetization of data in the right way. We can do that.
Awesome, awesome. So now I want us to move on to, I mean, you mentioned earlier on that you also have got like GPUs on your platform to cater for things like, um, cutting edge computer vision sort of like technologies. And quality control is one of the major use cases in AI manufacturing that utilizes computer vision. And one of the things that I found interesting when I was kind of like really looking into your platform is your partnership with Lending AI to deliver computer vision based quality control solutions. So maybe first of all, for the benefit of the audience here who may not be familiar with who Lending AI or what they provide, just kind of like give us a brief introduction into that, and then explain like how this collaboration of Snowflake with Lending AI actually works and how does it benefit manufacturers.
Yeah, definitely. Landing AI again is founded by pretty popular person Andrew Hingy. I think there are I would say thousands of videos in YouTube
Yeah.
on AI and ML. Is one of the foundational person to set up AI and ML at Google, and founder of Coursera. The landing AI was founded by him. A whole bunch of AI and ML computer vision experts, and they also have an pretty, I would say, differentiating solution on this area. They are in the process of building similar to LLMs. They are building LVMs, large vision models, for handling whole bunch of requirements around the computer vision topic. Again, there are multiple reasons why we partnered with them. These are some of the reasons. They are experts in this area. So again, I think we worked with them to build what we call it as a native app. It's a fully built application which runs within Snowflake. You can literally download it from Marketplace and use it, and there is no complex installation process or anything involved here. Okay, you can download it from Marketplace and go from there. And also this solution, as you know well, computer vision, as you know, you can build a model in the cloud, which is needed with all the compute power needed to build convolutional neural net models for computer vision use cases. But most of the time, the solution inference will happen at the edge because that's how most of the customers want. And they're round tripping huge volume of vision data, which you may or may not store for later usage. Sending to the cloud doesn't make sense. 95% or more than the customers out there would want to do inferencing at the edge. Again, landing as a landing lens application, which also an edge application available, which connectivity into smart cameras, where you can ingest the data. You can program the PLCs to take pictures as and when the part is coming out of the line, and you can trigger the inferencing out there. So it's a fully built solution where you can streamline highly manual, you know this, again, quality control process today, most of the companies is highly manual in nature. Very few people have adopted computer vision, even though this technology has been there for ages, but the price point has always been high. But with cloud vendors providing convolutional neural network support with GPUs in the backend, the price point has come down significantly, but it's still not adopted hugely by manufacturers. That's why this is a huge white space market for Snowflake to go after. With us supporting GPU capability, this has been my number one target, to work with a player like Landing to build and launch the solution. There's a whole bunch of differentiating aspects of the solution. We'll get into that, but we launched it literally, I would say, in June, first week in our annual conference summit, which, by the way, next year you definitely should attend. I will send you the
Yeah.
tickets as well. But having said that, we launched it in June, and we have multiple engagements going on with customers around the world. Huge interest in the market. So yeah, I think that's pretty much what we have done. Try to take a highly manual process and also error-prone process. Humans can only do so much defect detection. Once the size of the defect goes beyond certain range, you need a different mechanism to do that. Also, the third issue with this manual quality control, it's pretty slow, error-prone, slow. We all know that. I think that those are the challenges which we go through. That's what we are trying to eliminate with this pre-built solution. Okay.
Awesome. Super interesting. So you made reference to LLMs or foundational models, which are really becoming essential for sort of like scaling AI-driven operations in many sectors, really, but manufacturing involved in that. So as a way to deliver capabilities of foundational models to the industry, you recently also launched Snowflake Arctic, which I believe is an enterprise-grade large language model. So could you kind of like describe how manufacturers can leverage Snowflake Arctic in integrating sort of like foundational models for their use cases, and maybe kind of like just give us a brief description of what Snowflake Arctic is
Yeah,
first?
definitely. Snowflake Arctic, as you mentioned, it's an enterprise-grade large language model we built and launched from Snowflake. Again, we are not exclusive to only that. If customer wants to use other models like Mistral out there, they can use it within Snowflake environment as well. So this comes under our, what we call it as AI and ML umbrella, called as Cortex series of offering. Arctic is one of those models you can leverage here. I would put it this way: LLM adoption is happening much faster than AI and ML adoption overall. We have seen this in the industry. The hype cycle is going through much more rapid rate than anything else. I'm sure you're seeing this as well.
Oh, yeah.
The biggest usage of LLMs in manufacturing world, I would say that it is around democratization of technology, enabling citizen developers. Because today, if you have to go generate, for example, a fancy dashboard or write a SQL query to pull data from a bunch of tables, somebody has to do that manually. So these are the areas quickly LLMs can generate those SQL code, where in a chatbot kind of interface, you can ask questions on, hey, what time this kind of quality issues are happening? And can you tell me what is the OEE calculation? You can easily generate a SQL in the backend, which we do today as part of our Arctic LLM, where SQL generation is possible. And we are also working on a whole bunch of capabilities you will see in the future, where in addition to that, complete charting capabilities, where I want to plot last 3 months worth of energy consumption correlated to a certain shift, certain line, certain machine. That level of work is always possible. That's where we are already seeing customers interested in applying LLM, where you leverage a conversational mechanism to navigate the data. And also, you completely democratize the technology, where you don't have to write code anymore. You don't have to do Python coding. You don't have to learn SQL scripting. The LLMs do it for you. That's a power where we are seeing. That's where we are seeing a lot of interest with the customers as well.
Awesome. So I know LLMs are trained, like different kinds of LLMs are trained to be like powerful in specific areas. Is it so? I just want to kind of like understand from your point of view with Snowflake Arctic, was it trained for to be superior in a specific area as compared to other LLMs? Is there something to say there?
No, I think it is it's still like any other LLM. It is meant to handle the traditional use cases by going through all the information in the web. But added to that, we have also provided capability to generate SQL generation and capabilities like that with Snowflake that we support today. Okay.
Oh yeah, absolutely. All right. So I mean, now to kind of like help our viewers and listeners understand like the practical applications of AI in manufacturing on top of the Snowflake platform, can you share a specific case study where Snowflake's manufacturing data cloud kind of like was used in a real manufacturing scenario or industrial scenario, where a customer really kind of like managed to optimize their sort of like data use cases on top of your platform?
Yeah, definitely. There are a whole bunch of customers, if I have to point out. The biggest one out there would be Siemens, where as part of their cloudification journey and trying to get deeper insights with AI and ML, um, they moved away from SAP HANA-based analytics into Snowflake using our data mesh foundation. That is a huge reference use case for us, for them to use. That's one of the largest SAP implementation in the world is within Siemens, across their manufacturing facilities, hundreds of manufacturing facilities around the world. By We accelerated the journey and also brought down the cost significantly. The price point involved in running analytics, I'm talking about significant. It's well published use cases out there. Similar to that, if I have to point out in manufacturing area, Honeywell is another good example for us. And another two areas, maybe not in strictly as in running production industry 4.0 smart manufacturing use case. The other two customers who are reference for us is Toyota. They presented in our summit this year in June. Their complete connected mobility data is being managed within Snowflake for them to derive deeper insights and analyze all the diagnostic trouble codes to a whole bunch of other connected data coming in. Similar to that, Scania is another good example for us for ages. They have been managing complete connected truck data, 300,000 plus trucks into Snowflake, brought down their complete telecom bill significantly with Snowflake adoption, along with analyzing a whole bunch of issues happening in the truck, things like that. And these are the ones I can easily point out. We have more customers than that as well. Okay.
Do you perhaps have any best practices that you would recommend to manufacturing leaders who are looking to adopt AI in their operations, or maybe like some key steps that they should sort of like look through doing to maximize their chances of a successful implementation?
Oh, definitely. There is a whole bunch of best practices we have in place, which we leverage as part of the journey, either on our own or working with amazing partners we got today. The first one we always work with the customer is there has to be a well-defined business use case out there. It cannot be I have a hammer, I'm going to look for a nail. Usually it never successful. Have a well-defined business use case which is driving this initiative. And also when we start this journey, once you have the business use case in place and where they want to go, establish the data foundation is always the first step we go with, whether it is IT data, OT data, or both of it, or even third-party data. Some of the scenarios in supply chain, they would want to bring in weather information, traffic information to derive insights. What are those data sets which are needed? How do you make that available at scale within an environment like Snowflake is becomes so crucial as a first step. And once these things are in place and once the use case is in place, usually, again, this is not our approach. This is a standard recipe for success. Don't try to boil the ocean. Let's take one simple problem statement within one facility, one line, maybe one machine, prove it out. And while we are doing this, proving this out, understand your broader ecosystem, understand the maturity of your own facilities. Because in manufacturing, most of the companies, the maturity of two different facilities are not the same, because most of the companies build their manufacturing ecosystem by acquisition over a period of couple of decades. So you have Second World War era machines in one place, much more modern machines in another place, some with very good Wi-Fi connection, maybe not with other areas. And the user education level is also very different depending on where the acquisitions come from, where the facilities are present. There has to be a much more broader study done on maturity of the plants, use case priorities, business use case, because for the same company, between a final assembly versus powertrain versus stamping, use case needs are different. We have to understand what are the library of use cases which is important. So whatever you build, where you can take it next, because you cannot build one stamping predictive maintenance use case and take it across the facility. It's not applicable. Maybe energy optimization that way is far more universal in nature. Pick a use case like that if that becomes more important. So that's what we do as part of the journey. Well established process. I'm also working with pretty good partners, like Reply is a major partner for us. Amazing team of individuals under Remus. We work with them closely around a lot of these OT kind of initiatives as well.
Awesome. Awesome stuff. Yeah, so I mean, what is kind of like really clear here for a lot of people, myself involved, is that the future of manufacturing is really likely going to be shaped by this continuous improvement in AI and data analytics. And so, what I want to get your thoughts on is, based on your insights and perhaps the vision of Snowflake, what are some data-driven predictions for the future of AI in manufacturing? Where do you see the biggest transformations happening in the next few years?
I think I would say AI adoption is already becoming more and more mainstream. But if I have to look at an area where we see a lot of trend shift happening, it's applications. There is not enough applications out there. Even today, once the data lands in a cloud environment, let's assume we have brought the data in scale. Okay, now you can realize the value. There is not enough applications which customers can leverage because needs of customers are different. For example, even if I have to take at a high level, energy optimization is a use case. The other one could be, how do I do compressor maintenance better? Other use cases is HVAC performance in my manufacturing facility, stamping operations, applications which can target towards a specific class of machine or manufacturing processes are of huge importance. That's why we are pushing the trend by working with players like Landing to build that pre-built application with which customers can immediately perform quality control. That is the trend shift we are seeing because that's a natural progression of events. You have provided them a platform where you have the data available, you have commoditized the data, you have given them tools where, like AI ML tools, LLM kind of portfolios, where you can make sense of the data better. But we need now more and more people with expertise, partners to jump on board, work with players like us, and build these kind of native apps. That's where we are seeing a lot of interest out there. Again, that's where I am seeing a lot of trend shift happening because this is what I'm seeing today. Compared to 3 years back, now more and more people are reaching out to us asking, hey, how do I build this kind of apps on your environment? Help us on this journey. So you will hear more and more announcements as well from our side on this front.
Awesome. I mean, that's super interesting to hear you say that because I remember a previous guest of the podcast here mentioned something to that effect, that we are coming from an era where we used to give the OT folks or the manufacturing folks some tools where they need to build models for themselves, and they're really not experts, right,
Right.
in that field. So it makes sense when you say that now we're kind of like moving into an era where applications built by experts are kind of like
Yeah.
really being used to make sense of the data. So that's
Right.
super
Right.
interesting.
Yeah. The other one, if I have to point out, since I think what you brought up is super important, citizen
Mm.
development. That is a reality because the amount of use cases possible, even in a very simple manufacturing facility, is way too many. A centralized IT organization serving every possible needs of manufacturing users at the plant floor is next to impossible.
Yep.
That's a reality. So that kind of portfolio is getting more and more prominence. We are already seeing it, and that's why we are also working with a whole bunch of low-code platforms on this area. Players like Mendix from Siemens, Tulip.
Yep.
We see them shifting the environment towards end users, quickly building out an app without knowing coding. That again accelerates the value realization process because once the data is accessible, technology is democratized with low code platforms. um, it's a no-brainer for if manufacturing end users to access the data, which was always considered as extremely complicated and always people operated on stale data. We have removed all those complexities. That's where the industry is again going to go.
Yeah, absolutely. Pugal, thank you so much for taking the time to join us here on the show today. Do you perhaps have any last word or something that we didn't touch on the podcast that you want to say to our audience?
I think no. I think we pretty much covered nearly all of it. And again, feel free to reach out to us. We are doing a lot in this area. Anytime if you have any questions, comments, yeah, feel free to reach out to us. Thank you. Thanks for hosting me as well.
Absolutely. Thank you so much. So that brings us to the end of this session. Thank you and see you soon.
Yeah, awesome. Thanks, Kudzai.